Alright guys, we're going to talk about some problems from the Unit 1 section of your midterm review. The first thing I want to talk about is opposite rays. Opposite rays means you've got two rays going in opposite directions. Here, I've decided to use the same point B, and then list the rays that are going in opposite directions. That'd be BC and BD. Number 4 is asking for another name for ray CD. Ray CD starts at C and goes all the way to D. Well, which ray is the same thing as that? Another name for that would be ray CB, because it starts at point C and it continues on in the same direction. Now we're going to move on to the next section. I would recommend you draw a picture for this section. It says point J is between H and K on segment HK. So the first thing I'm going to do is draw a picture. You've got a segment HK, and J is somewhere in the middle. It doesn't say it's in the exact middle, but it does say it's on the line in between H and K. I need to use the information given in order to solve for X, and then go back and plug in for HJ and JK. Number 7 tells me HJ is 5x minus 4. JK is 8x minus 10. And then it tells me KH, this entire thing right here, is 38. What we're going to do is use something called the segment addition postulate that tells me this piece, HJ, plus this piece, JK, equals the total, 38. So I'm going to add these two and set them equal to 38. The first thing you would do is combine like terms. 5x plus 8x is going to be 13x. You've got that negative 4 here. Minus 10 or plus a negative 10 gives you a negative 14 equals 38. From there you would add 14 to both sides. Cancels, add 14 over here, and you get 52 equals that 13x. From here you would divide by 13 on both sides. Divide by 13, cancels, divide by 13 here. Let's see, 4. X is going to equal 4. 52 divided by 13. And from there, once you found X, you have to go back and plug in to find HJ and K. This is a great way to double check your answer when you plug it in. So if I plug in here for X, 5 times 4 is 20 minus 4 makes this piece 16. 8 times 4 is 32. 32 minus 10 is 22. And when I add 16 plus 22, it will 38 if I did it correctly. And in this case, it does. So, HJ is equal to 16. And then JK is equal to 22. Segment addition postulate. Problem number 9 is asking for the distance between the 2 points. And I want to leave my answer in simple numerical form. Whenever it's asking or the distance, that should ring a bell. You're going to use distance formula. You have to have that distance formula memorized. I'm going to do my work on a separate sheet of paper. Point A is 2, 1. Point B is 6, 6. The first thing I want to do is label my point. X1, Y1, X2, Y2. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, you got to have that memorized. From there, you can plug in. X2 is 6 minus x1 is 2 squared plus y2 is 6 minus y1 is 1 squared. And then you want to simplify it. 6 minus 2 is 4 squared, plus 6 minus 1 is 5 squared. 4 squared is 16, plus 5 squared is 25. 16 plus 25 is 41. So you get the square root of 41. And then you want to keep it in simplest radical form. Simplest radical form means you need to think about ways that this guy can break down. I don't know about you, but I'm pretty sure 41 is prime, so he doesn't factor into any two numbers. So because he is simple and prime, he can't be broken up. He doesn't have any pairs that can come out of the radical. The square root of 41 should be your answer. If you look at problem number 11, it's asking for the same thing. It says you've got two endpoints of each segment, and you have to find each segment's length. That's another word for distance. And then tell whether or not they're congruent. So those distances should be equal to each other if they're congruent. So I'm going to do the same thing that I did on the last problem. Use that distance formula on a separate sheet of paper. J is at 1, 1. K is at 0, 5. Label your points. X1, Y1, X2, Y2. Plug it into your formula. The square root of X2, which is 0, minus X1, which is 1, squared, plus Y2, which is 5, minus Y1, which is 1, squared. Again, this is coming straight from the distance formula. From here, 0 minus 1 is just a negative 1 squared, which is 1. 5 minus 1 is 4. 4 squared is 16. So you get 1 plus 16. 1 plus 16 is 17. So you get the square root of 17. 17 is also prime, so it does not break down into any factors. So you are finished here. But the problem didn't just ask for the length of JK, it asked to see whether or not it was congruent to LM. Point L is at 1, 1, and point M is at negative 3, 2. And so I have to find the distance formula, I have to use the distance formula to find the distance between those 2 points. Same kind of thing. Label your points, X1, Y1, X2, Y2, and plug it into your formula. X2 minus X1 squared plus Y2 minus Y1 squared. Negative 3 minus 1 is a negative 4 squared. It's going to be 16. 2 minus 1 is 1 squared, which is 1. 16 plus 1 is 17, so you get the square root of 17. Because these are equal, then yes, my segments are congruent. Moving on, we're going to talk about number 13. Number 13 says use a protractor to find the measure of the given angle. Then classify it as acute, obtuse, right, or straight. I want to look at angle AFB. Remember that middle letter always represents the vertex of your angle. So I'm going to go from from letter A to letter F to letter B. So you want to put the vertex right at the center of your protractor, and you want to make sure this line is aligned with one of your sides of your angles. Then I'm going to look and see where does this line extend in regards to my measurement. The problem here is that B, if you notice, is too short. I can't get an accurate measurement for my angle. So what I'm going to do is use my protractor to just extend that line out. You want to get B to be extended so that it runs into your protractor and you can get a good read on it. Oh, and I didn't extend it long enough, so I'm going to keep extending that point, or that line, all the way out. So it runs right into my protractor. I make sure that my protractor is aligned right. And then B, if you notice, it's going to intersect right at 51, 2, 3. 53-degree angle. Notice it also looks like it intersects at 126 degrees. But what I know is that this angle right here, angle AFB, is an acute angle. So it cannot be 126. That would be angle EFB, this large angle over here. My angle, angle AFB, is going to be equal to 53 degrees. And that would be an acute angle because it is smaller than 90. Then I'm going to look at AFC because that's angle 15, or excuse me, number 15. Like I did with B, I want to take my protractor and I want to extend that line for C out so that I can really get a good read on it. Just going to take my protractor and from point S, extend it out. This will give you the most accurate measurement. Then you line up point F, your vertex point, right at the center of your protractor. And from A all the way to angle C, it's going to be more than 90, so it's going to be an obtuse angle, which means I'm going to be looking at the larger number. It's over 105, but not quite 110. It's right at 108 degrees. So for number 15, it's 108 degrees, and like we said, that would be obtuse. Moving on, we're starting to talk about some vocabulary. This section is talking about supplementary angles, complementary angles, vertical angles, and linear pairs. Supplementary angles, I know, are always going to add to be 180. Complementary angles, I know, will always add to be 90. Vertical angles are always directly across from each other. And a linear pair also adds to equal 180. There are two angles that create a straight line. When I'm looking at my problem, it says this is a roof, and it can have several different layouts. The diagram below shows one type of roof truss made out of beams of wood. Use the diagram to identify different examples of the indicated angle pair. It does tell me that angle HBC, so this whole angle right here, is 90, and BCE, this whole angle right here, is 90. Okay, because it tells me it's a right angle, and those are the same thing. So for number 17, I'm looking for angles that add to equal 180. I know 180 degrees is a straight line, so I can take any two angles that add to be a straight line and put those together as supplementary angles. I know this angle right here plus this angle right here equals that straight line, so that's the one I'm going to use. This is going to be angle AHB, this angle right here, H is the vertex, and angle BHG. Those are going to be supplementary angles. You could also do even this angle here, HGB, and here, JGF. There's a lot of different examples of supplementary angles here. Vertical angles are going to be any two angles that are directly opposite each other. There's a lot of vertical angles here. I'm just going to choose two. I'm going to come right over here to the other side and just choose this one and this one. But like we know with vertical angles, the other two in that pair are also going to be vertical angles. So you can use three letters to identify angles. if I'm identifying this angle right here, I'm going to use CKD, angle CKD, and angle EKL, angle EKL. And notice your vertical angles have the same vertex. So number 19, that would be my answer, and angle EKL. And then number 17, my answer was angle AHB and angle BHG. Like I said earlier, you could have a lot of different answers for these two, and even 1820, you can have a lot of answers for those two. Number 21, this next section is talking about explaining whether or not something is a polygon. If it's a polygon, I know it has to be closed, has to be a closed figure, and it has to have straight sides. So number 21, is it closed? Yes. Are all the sides straight? Yes. So it is a polygon. Then I need to tell whether it's convex or concave. Concave always bends in like a V. So does this have a point of concavity? Yes. And that would be right here. If it has anything that's concave, then it's declared concave. Number 23, is it a polygon? Well, does it have straight sides? Yes. Is it closed? Yes. So yes, this is a polygon. Then I want to think, is anything caving in, like a V? And you might think this right here looks like it might be caving in, but it's actually not. It's still convex. It's still pointing out. Concave has to have something like this to make it concave. Number 25, the perimeter of a rectangle is 690 inches, and its length is 213 inches. Find the width of the rectangle. I'm told that the perimeter is 690. So the first thing I want to do is think, what formula do I know for perimeter? If it's a rectangle, then I know perimeter equals 2 times W plus 2 times the length. I know it's given me the length is 213. So I want to plug that right in here. And then I can solve for W. So I'm given the total P here. So 690 equals 2W plus 2 times 213. 2 times 213 is 426 plus your 2W equals that 690. From there, I need to solve for W by subtracting 426 from both sides. Minus 426. Let's see. Carry that. You get 4, 6, 264 equals that 2W. If I want to solve for W from here, I need to divide by 2 on both sides. So W is going to equal 132. I can always go back and double check my work by plugging it in. If my perimeter is 690, then it should be the same thing as my widths added together plus my lengths added together. You can go back and double check to make sure that this plus this plus this plus this equals that 690. The window pane problem is a doozy for a lot of students. You're told that the window out of a rectangular pane of glass is surrounded by a wooden frame that's X inches wide. The pane of glass is 20 inches long and 24 inches wide. The perimeter of the window is 8 2/3 feet. What is the value of X? The first thing I notice is that all of my measurements are given in inches except for my perimeter. So the first thing I want to do is get that perimeter into inches by multiplying 8 2/3 times 12. We know that 8 times 12 is 96, and then 2/3 times 12 is 8. So you get 96 plus 8, which is 104 inches for your perimeter. So that's going to be the perimeter of the entire window, which includes the frame. From here, I know that perimeter of a rectangle, just like we saw before, is P equals 2 times the length plus 2 times the width. I know the P, the perimeter, is 104, so I can put that in for P. Then I rewrite my formula as 2, and instead of the L, instead of the length, I'm going to write what I have here, which is 24 plus 2 x's. 24 plus 2 x's, because 24 plus each side of the frame is x, so that's 2 x's. Then you plug in for your width. Instead of plugging in W, I'm going to plug in 20 for the window glass, and then plus x, which is plus 2x for the frame. From here, I can solve for x first by distributing. 2 times 24, 2 times 2x, 2 times 20, 2 times 2x. I'm going to rewrite that over here. 104 is going to equal 48 plus 4x plus 40 plus 4x. And that's just me distributing. I'm going to combine like terms here and here, as well as my x's. 104 equals 88 plus 8x. Then I need to subtract 88 minus 88. What do you get? 16 equals 8x. Then you would divide by 8, and x is going to equal 2. That's all it asked me to solve for, was the value of x, so I'm done. Next, I'm going to look at number 29. It's asking to tell whether the angles are vertical, completely opposite each other, a linear pair, they add to equal 180, or neither. Angle 1 and angle 2 together make this straight line here. So that's going to define them as a linear pair. Just a few more problems I want to work out for you. Hopefully this has given you a little bit of information about each section so you can be successful on your own. Number 33, if I'm going to solve for the value of x and y, the first thing I have to do is look at my angles and see what do my letters have in common. When I look at my x's, if I compare those two angles, I know that together they add to equal 180, because together they are making this straight line. So I'm going to add them together and set them equal to 180. I combine like terms. 6x plus 15x is 21x, plus 75 equals 180, minus 75 on both sides. You get 21x equals 105. Divide by 21 on both sides. You get x equals 5. So I solve for x, but I'm not quite done because I need to solve for y. You can do one of two things. You can take x and plug it back into here and solve for that angle and set that equal to y because those are vertical. Or you can take that x and plug it into here and say that this angle, 6x, plus that angle, 3y, has to equal 180. It's up to you. I'm going to use this one right here because I know that this makes a 30-degree angle. 6 times 5 is 30. So I'm going to take that 30 degrees plus whatever 3y is, and I know they have to add to equal 180 because those two are a straight line. Subtract 30 from both sides. You get 3y equals 150. Divide by 3 on both sides, and you get y equals 50. So I've solved for x and I've solved for y on number 33. X is 5 and y is 50. Next I'm going to look at 35. I look at the letter that two angles have in common. Here it's the x again. And I think, what do those two angles have in common? What kind of formula am I going to use to solve for that letter? They're not equal to each other because they're not vertical, but they do add to equal 180 because they make a straight line together. So you're going to take this piece right here plus this piece right here and set it equal to that straight line 180 degrees. So 28x minus 7 plus 24x plus 18 equals 180. You're going to combine your like terms. You've got 28x plus 24x, which should give you 52x. Then you've got a positive 18 and a negative 7, which gives you a positive 11 equals 180. From there, to solve for x, you would subtract 11 on both sides. And you get 52x equals 169. Then you would divide by 52 on both sides. 169 divided by 52 equals 3.25. Okay, I'm just going to go back and double check my work, make sure I did that correctly. 28 plus 24 is 52. X. Negative 7 plus 18 is a positive 11. And all that's adding to equal 180. Minus 11 on both sides. You get 169, and then you would divide by 52. That's right. I just like to double check my work whenever I get a decimal. But from here, you're going to go back and plug in, just like we did in the problem beforehand. You could plug this x into this equation and set it equal to that vertical angle of y. Or you could plug it into here and then add these two and set them equal to 180. It's up to you, but I'm going to plug it into that first one. So 24 times 3.25 plus 18, and I'm going to set that equal to y because they are vertical angles. 24 times 3.25 is 78 plus 18 is 96. So you get 96 equals that 12y plus 30. From here, I would subtract 30 from both sides. You get 66 equals 12y. Divide by 12 on both sides. You get y equals 5.5. Those are not coming out pretty. Alright, you guys, well, that's it for the Unit 1 review video. It's about 30 minutes. I think that's enough. Take a break, grab something to drink, to eat, and rest your brain for a minute. Look at Unit 2 if you need some help.